Hello, we are the Three Musketeers.
George Barrera,
Beth Langdon, Ashley
Ashley Cheeseman.
Cheeseman, and I, Allison Oaks. Our two experiments we are doing are coin spinning and vision testing. Our project requirements were to create two 3-variable design of experiment experiments. Test 4 combinations for each, test the final optimal combination of each, and then perform calculations to find out the interactions between variables and the contribution of each variable to the total outcome. Our first experiment is coin spinning. In this experiment, we will test 3 different variables: the coin type, either a penny or a quarter, whether it has a rubber band around it or not, and the ground surface on which we test it, the table or carpeting. We're trying to see which coin will spin for the longest amount of time. We chose to do this experiment because the materials were all readily available and very cheap, and it was easy to test and measure the outcome. These are our results. We did 4 combinations. First, a quarter without a rubber band on a table. Then we tested a quarter with rubber band on carpet. Then we tested a penny without a rubber band on carpet, and a penny with a rubber band on the table. These are our average spin times for each trial and the standard deviation. These are the second half of our results. We had the level 1 average spin time, and then we did it again level 2 for A being the type of coin, B the rubber band or not, and C the surface on which it was spinning. And there's quite a big difference between each one. We predicted from this data that the optimal combination would be a quarter with no rubber band on a wooden table, and the predicted spin time was 12.9 seconds. The actual results were very close. We almost predicted it spot on. So these were our variable calculations. We had different interactions: the coin and the surface, the coin with the rubber band, and the surface interacting with the rubber band. And the individual influences were the coin, the surface, and the rubber band. These are the effects of variables on the time, the total spinning time. The rubber band with it had a negative effect. Without was more of a positive effect on time. The material, we found that spinning on a table was definitely better, and a quarter spun better than a penny. And then you have our average time, actual data. Okay, these are the magnitudes of the effects that we calculated. We used the sum of the positives over 2 minus the sum of the negatives over 2 to find out our magnitudes. And you see that the material, whether it's spinning on carpet or a table, had the highest magnitude effect. These are our different interactions and their magnitudes. Rubber band versus the coin type had a 7.025. Rubber band versus material, or the surface, had a 5.195, and the material versus the coin type had a 5.095. In conclusion, the material, or the surface on which it was spinning, had the greatest effect on how long the coin spun for. The rubber band versus the coin type interaction was the greatest between 2.
Our second test was the vision testing. I don't think that's
And then just hit resume. It'll work. Right. For this experiment, we tested the variables of which person, we had Beth and Ashley, whether the person was squinting or not, and the screen brightness, whether bright or dim. The desired outcome was to find the longest distance that a person. In our results, we had 4 combinations, and we found that the best combination was to have Beth not squinting with a bright screen. This is our level 1, our level 2 average time for for the three variables. A is the person, B is whether they are squinting or not, and C is the brightness of the screen. The predicted optimal combination was to have Beth squinting with a bright screen, and we predicted that she could do it from 28.6 feet away. And the actual results were very close. These are our variables that we had to calculate: the person with the brightness, the person with the squinting, and the brightness with the squinting. And the individual influences were the person, the brightness of the screen, and whether they were squinting or not. This is the effects of the variables on number of steps away, or the distance. Here we have, and we also have the average number of steps in a quantifiable value. These are our magnitudes. Squinting had a negative magnitude, and the people had the person had the biggest magnitude of effect. These are interactions and their magnitudes. And in conclusion, the person that was reading the word had the greatest effect, and the people versus the brightness and the people versus squinting interactions were also the greatest.